Hello friends. So today I am going to do the one-way ANOVA using the RStudio. So for this purpose, I will use the tooth growth data set already present in the as a it is present as a inbuilt data set. So I'll convert this tooth growth data set into another with another name DF. DF is equal to tooth growth. Okay, so if we just see this is the first 6 rows of this DF column. Okay, and we can see the structure of this data frame. So structure, you can see that there are 3 variables: length, supplementation and dose. So now because we are going to do the one-way ANOVA, so we will remove one factor. So supplementation will remove. Second thing is that dose is a factor variable, but here it is showing as numerical variable. So we'll have to convert this dose into the factor variable. So first of all, we will have to remove the supplementation variable from here. So for this, we will use the dplyr package. We'll load the dplyr package here. After loading this, now we will use the select function. Df is equal to df, then the pipe operator, and then select function and minus supp. So this will remove the supplementation factor. So if I repeat the structure command over here, you can see that the supplementation factor has been removed. Now next thing is we'll have to convert this dose into a factor variable. So for this, df $sign dose is equal to as dot factor, then df $sign dose. So if you see the structure of the data frame now it's okay. So the dose has been converted to a factor variable. Okay, now next thing we are going to do is to carry out the ANOVA. So for this, we will use the AOV function and we'll name it as df.ANOVA. It's a name, just we are giving a name, AOV. Then first of all, the response variable versus dose. Then the name of the data frame is df. So I can see the summary over here, df.ANOVA. So you can see that the dose has got significant, that means the different doses has significant difference among themselves. That's why the p-value is very less. It is highly significant. Now the next thing that we are going to do is the post hoc ANOVA, that is the multiple comparison. So you can, there are many methods. So among them, like one is the Lsd test, then least significant difference, then Duncan's test. We will perform all one by one. So first of all, we will perform the Lsd test. So before that, we will have to load another library, that is we have to load a package, that is agricolae library, agricolae. After loading this package, now we use the Lsd test first. Lsd test. Then after that, the first thing that we should do is we'll have to put the name of the ANOVA, because we have, if you remember, the name of the ANOVA that we have given is df.ANOVA. So we put here df.ANOVA. Then the next is the factor variable. So our factor variable, we'll have to put the factor variable inside the quote. DOSE, dose. Dose is the factor variable. And then group is equal to true. Okay, and then we just name this Tucky's comparison. We just give a name over here. So we just name it as TK, and then we run the command, and thereafter just type TK. So here you can see the output. So this is the len and this is the dose 0.5, 1 and 2. There are three different doses. So this is the average of these doses, mean value. This is the standard error. This is the number of replicates, minimum value, maximum value, then 1/4 quartile, half quartile, 3/4 quartile, all these things. And then this particular thing is of our interest. What you can see is that here at dose 2, and then the dose is 2, then you have to put the A. So here A, B, C, whatever you are seeing over here, these are the compact letter display. That means when you will report this, what you will do, you will write that dose 2, the length is 26.1, okay, and over this either superscript or subscript you will have to add it A. Then in dose 1, in this mean value you will have to add the superscript or subscript as B. Similarly, for this you have to add here C. So this is the way how we report the. Okay, now this was what we have done is the Tucky's test. Now next is we are going to do the LSD test. Okay, so we name the LS as LSD only. LSD is equal to Lsd test. So now here what we will do, first of all we will have to give the name of the ANOVA that we have performed. df.ANOVA, then comma, under the quote we will have to write the name of the factor variable DOSE, dose, and then group is equal to true. So again simply type LSD. So here the same result you will get, but this result you have to obtain through the least square difference, least significant difference. Okay, now the next thing that you should do, you can do is the Duncan's mean range test, Tucky's test, then LSD test, and the third one is the Duncan's mean range test. That also I'll show here. So just we call it DMRT is equal to Duncan.test. Then here we first of all we put the name of the ANOVA. So the name of the ANOVA is, this is what is the name. Then the factor variable dose, and then just put group is equal to true. So group is equal to true. This particular function ensures that you will get the compact letter display. Okay, now just see. So this is what is the compact letter display ABC you are getting. Okay, so this is the very nice way of reporting, and it makes the task easier. So if you like this video, so give some suggestions, or if you have any questions, you can put it in the comment box. I will be happy to answer your questions. Thank you very much.